In this episode of Building a Layout with Bachmann, we lay the groundwork for track assembly, put our plan to the test, build up initial base topography, and wire our railroad for operation. In the previous episode, we finalized our track plan and constructed our benchwork. Now it's time to put the plan into action to see if it will work in the real world. Before we begin laying track, we need to add a base layer of 1-inch insulation foam board available from all good hardware stores. For durability, we recommend using a heavy-duty construction adhesive to attach the foam to your baseboard. The foam layer will go a long way in helping to dampen sound and vibration when trains are in motion, and the material can also easily be cut into. With the foam base installed, it's time to lay the track, but not permanently. We spent many hours developing our plan on paper, but putting it to the test is a whole different ballgame. We need to find out how our trains will handle turnouts, crossovers, and curves in real life, and the railroad needs to perform just about flawlessly before we can move forward, as any potential issue could mean a major change in design, a problem you don't want to be stuck with further down the road.
So now that the layout's together, the next step is to test it with a train.
With the track in place and a single terminal re-railer temporarily powering the layout, our test train begins its maiden trip. On our trolley loop, we're using our tightest available easy track radius with 15-inch curve sections, so we're testing this loop with a trolley rather than the train. In reality, trolley lines are typically constructed with tighter curves than mainline railroads, so this is completely appropriate for this area of the layout. With our test complete, we can now proceed with the layout build, knowing that we won't run into problems with the design at a later stage. Before we move forward, we have to first remove the track again. Our design calls for the main line to be elevated slightly from the base layer, to allow for more scenic depth in the foreground. We plan to include a waterfront around most of the visible side of the layout, to provide a plausible low-level foreground scene that won't get in the way for product photography or video. Even if photographic angles aren't a major consideration on your railroad, elevating the track above your base is a good idea, as it will allow for construction of natural-looking topography around your rail bed. The loop on the left side of the layout will remain relatively level, since the planned yard and industry tracks will leave less room for variations in elevation. This area simply requires a standard 4x8 sheet of foam, adhered to the base layer using the same heavy-duty construction adhesive used earlier to attach to the baseboard. For the central section on the right-hand side of the layout, we'll need to cut the foam to size. To do this, some of the track sections have been left intact, lifted over the new foam, and traced to provide a guide for where to cut. Shaping the foam can be done with a hot wire foam cutter, available from many hobby and craft retailers, but in some cases it may be easier to cut with a foam knife by hand, especially when it comes to larger sections. After cutting, it's time to place the foam sections on the layout. At this stage, it doesn't matter if it doesn't look perfect, as this is only a base for the topography. Everything, including small gaps between segments, will be covered up before scenery is installed.
It doesn't have to be perfect because when we start doing our scenery, we're going to do a top layer to cover up all this pink foam board. So we're kind of using these scrap pieces from when we cut out the big boards to help us basically frame out where the track is going to go on top of it.
To add more scenic and photographic interest to the layout, our design calls for the rear portion of the main line and the trolley loop to sit at a higher elevation than the majority of the track work. Having track at multiple heights is great for visuals, but it can present a challenge for construction. Luckily, there are a number of options for pre-built risers to ensure your track can make a smooth transition from one elevation to another. We recommend keeping the incline under 4% for best operational performance. Keep in mind that a real railroad will rarely be graded for inclines greater than 2.5%. To maximize the use of space on our layout, we're installing a 3% incline at each end of the higher elevation section, which raises the track to approximately 4 inches above the base roadbed, enough for a train to pass underneath, although our design doesn't specifically call for this. Now it's time to add the base layer of foam to form the upper level. This will act as a foundation for any further topography changes around the elevated track. We're again using the same type of foam board as found on the main level. To create supports, you can use excess foam from earlier in the process, cut to size, and stack to the appropriate height, as seen here. If using this method, make sure to spread out your supports evenly to create a firm, level base before applying your construction adhesive. Once these sections have dried, it's time to rebuild the track layout on your newly completed base topography. Our Easy Track provides enough flexibility to adapt to any reasonable inclines appropriately when laid. For a scenic element on the elevated section, we're installing one of our Easy Track girder bridges on the main line, which will eventually cross over a road linking the city scene to the rest of the layout below. With the track layout reconstructed, it's time to once again perform a test run. This will ideally be the last time the track will be installed before being fixed down, so it's important to ensure that there are no new concerns brought on by the elevation changes. Before beginning the test, make sure to do a railhead check by hand, just in case there are any joiners out of alignment. This is also a good time to check for clearances on curves using the longest piece of rolling stock you anticipate running.
So we got to make sure when a long car comes around here, it's not going to hit the retaining wall we're going to put along here. So 85 feet is about as long as we're going to get on a car on the inner loop here, so should be plenty of space for the retaining wall to go right there.
Once the entire layout has been checked, the train can depart for its trip. We're using multiple trains to cover all 3 loops at once, giving a first glimpse of the operational capabilities of our track plan. We can now turn our attention to completing the basic wiring for the layout. We'll continue to use the powered re-railer in the center of the layout as our main feed, but with a layout of this size, it can be beneficial to add additional power feeds to maintain even electrical distribution across the layout. You can use multiple powered re-railers for this, or you can solder feeder wires to the outside of the rails on conventional EasyTrack sections. Our 10-foot power extension wire will come in handy for either method. If you plan to solder connections to conventional EasyTrack rails, simply cut the square plug off and strip back a small section of wire to solder to the rails, making sure you maintain consistent polarity with which side is attached to which rail. At this time, we're also permanently wiring our reverse loop. The reverse loop allows a train to turn back on itself and run in the opposite direction on the same section of track it started on by automatically reversing the polarity as it traverses this section. We've installed readily available EasyTrack insulated gap tracks here and here, which are wired to our EasyCommand automatic reverse loop module. When the train runs over this section, the module automatically senses the movement and switches the polarity, allowing the train to keep moving with no interruptions. EasyTrack insulated gap tracks can also be used independently of the system to isolate power for specific purposes. We're also using these to isolate our programming track from the main line, as well as our DCC-controlled turntable. To use gap tracks as isolating sections, simply turn the power feeds underneath so that they no longer make contact for through running, and provide an independent power feed or terminal re-railer to the isolated section. Additional preparations can also be made at this stage for wiring EasyCommand turnouts for DCC control, although this step can be completed underneath the layout at a later stage.
All good.
With everything running smoothly, the track can now be fixed permanently to the layout. If placed directly on a wooden platform, you can locate a small hole provided near the end of your EasyTrack sections to install a track nail. For a layout with a foam base, this approach won't be as effective, so we're taking advantage of the realistic roadbed height EasyTrack is built to, and applying a layer of clear silicone caulk along the edges, keeping well clear of the track itself. Caulk is an excellent adhesive for this purpose, as it'll hold in place for as long as it's undisturbed, but can be taken up without damaging the track sections if you ever plan on changing your configuration. From this point, it's time to let your imagination run wild by building up your scenery and bringing your miniature scene to life. On the next episode, we start the scenery process, paint and weather our track, complete the base topography, and add hills, valleys, and tunnels.